Okay, alright. So today we'll be continuing the lesson 4 for the chapter Discrete Random Variable. It's also the second lesson for binomial distribution and it's also the last lesson for it. Okay, so for after today we'll be learning geometric distribution, so it might be like 1 or 2 lessons, then we will cover up the whole chapter for discrete random variable already. Okay, so my target for today's video is to finish everything like within an hour. Yeah, so to keep everything short. Okay, so for today one, you still remember for last time we already went through our first learning outcome, which is how to find the probability of each binomial for each possible outcome for your binomial distribution. Then after that, you also learn that what is the constraint for a binomial distribution. Okay, then after that for today we'll be focusing on the second learning outcome, which is how to find the expectation and the variance of a binomial distribution, so which is like pretty easy, so I hope that we can go through like faster today. Alright, okay, so just make some recap. So for the for the last lesson, what we have learned before is we learned what is the probability to get the R success in a binomial distribution, which is using NCR then P power to R then Q n minus R. So I hope that you already get yourself familiar with this formula. Then after that, what is that can be called by binomial distribution. So you must make sure that the number of trials that you are having are all independent, and then all your each trial must have only 2 possible outcomes, and for every trial the probability must be a constant. So with all these constraints satisfied, then you only can fit binomial distribution in that situation. Okay, so for today, let's move on to the introduction for today. So what is that mean by expectation and variance? So I will go through with you like one of the situation and help you to understand what is the expectation and the variance from a very common sense of like understanding, so you do not need to like memorize, you can really understand what is that mean. Okay, so a very easy one, so just grab your pen and then do it together with me. Okay, so the first thing is, let's see here. So imagine a fair coin is tossed. X is the number of heads obtained. So what is your P? So meaning what is your probability of success here? It will be 1/2. Correct? Okay, so meaning the probability for you to get number of head is basically 1/2. And then what is your Q? So what is your probability for you to get a failure, meaning you get a number of tail. It will be 1/2 also. Okay, the probability for you to get a tail. Okay, so imagine if this experiment is going to repeat it for 100 times, meaning that you have 100 trials here. What is the number of times your head is likely to be appear? So since the probability is half, right? So meaning if you are going to try this experiment for 100 times, then you expect it, meaning that without any accident happen in so-called, then what happen is you will get exactly half of it is like head, then half of it is like tail. Then how do you find out? Then you will use 1/2 to times 100. So basically you get 50. So you expected out of the 100 times, you are going to get 50 times of head. So this is basically what is that mean by the expectation or the mean of binomial distribution. Easy, right? Meaning that you expect is going to be 50 heads, which is what is your success. Okay, so the number of success that you expected is basically the mean or the expectation. Okay, so that's the first part. Okay, second part. Out of this expected number of successes, the number of tails obtained will be how? Okay, so you see, this is the expected number of success that you have, which is 50 times. So in the 50 times, is there going to, so you imagine if you try to do a real experiment, do you expect yourself to really get 50 heads and 50 tails? No, because there will be something like called, if you do an experiment, that it will be an error. So meaning that in real life situation, it cannot be like the real situation like in theoretical. So that's why out of this expected number of success, the number of tails obtained that I might get will be out of the 50 times of success, I have half of chance for me to get like number of tails. Is that okay? So meaning that what I'm trying to do is out of the expectation number of success, which is 50, I try to times the probability for failure. Then I get maybe out of this number of success, I will be able to get 25 tails. Okay, so what does that mean? This is basically called the variance. So meaning like what could be not going right in your experiment. Okay, so but 25, like this number is like quite big. You know why? Because the variance normally we will try to square it. So that's why now we need to do the square root. So we square root the variance and we get 5. So this is basically known as the standard deviation. So standard deviation is basically telling you in standard what is the number of tails. So meaning that what is the standard deviation actually mean? It means that when you actually toss a fair coin, the number of heads will appear in your 100 times of your trial. It will be, so your number of heads that you are likely to appear is like 50. So it will be like 50 minus 5 to 50 plus 5. So meaning in real life experiment, I expect and I allow an area of 5. So meaning the range that I roughly will got for the number of head is basically 45 to 55. So meaning like it's more practical now. So you see, instead of like telling myself that I should be able to get like 50, so meaning that's the best expectation that we have. But out of this, we also realize that there will be some error happen here and there. So that's why the standard deviation is 5. And then after that, meaning the range that we will be getting is like 45 to 55. Okay, so just to let you know, actually you do not really need to like understand what is the meaning behind it. So basically it's like you know how to find variance and standard deviation, but I'm trying to do everything like in a way that you can understand what are you going through. It's not like finding variance, then what does that mean by variance, I don't know, then what does that mean by standard deviation, that I don't know. So it's basically like an error that maybe perhaps will happen in your experiment. So that's why it tell me that maybe roughly I'll get a 45 to 45 heads to 55 heads, like rather than telling me that I will get an best expectation of 50. Okay, so now let's try to see this. Okay, so let's try it again with the same thing that we done just now with the fair coin. So now let's do the fair dice. Okay, so if x is the number of 6 obtained, then what is the probability of your success? So meaning what is the probability for you to get a 6? So it will be 1 over 6. Then what is the probability for you to get a failure? It will be 5 over 6. Okay, so let's say this experiment is repeated for 60 times. So what is the number of times that you expect 6? You expect to get out from the 60 times. Then you will use 1 over 6 times 60. So I expect the best outcome will be I get 10 times 6. Okay? Then after that, out of this expected number of success, what is the number of the not 6 for me to obtain? So it will be roughly out of the 10 times, then our times maybe from this 10 times, I'll be able to get a non-6 number, which is the probability for my failure. Okay, so when I times them together, I'll be getting a fraction of 8, 1 over 3. Okay, so this is not the answer because everything is in square. So now I want to find the square root. So the standard deviation is basically the square root of 8, 1 over 3. And then it will be giving me an answer of 2.887. Okay, so it actually means that when a fair dice is tossed, the number of 6 appear is roughly, so 10. The error that can be happen is roughly like this. Okay, 2, 10 plus 2.887. Okay, so but then you don't say like the number of 6 appear is like a fraction number. So when we try to change it, then it will be like roughly a 7 to 13, something like that. So you expect that in a batch approach, then maybe you will get 7 to 13 times of 6 appear. Okay, alright, so but it's the same thing that I said, so it's not necessary for you to understand like for the last part. So basically you know how to find the mean, you know how to find the variance, you know how to find the standard deviation, is totally fine already. Okay, so now let's go back to what we have done here and you try to understand how the formula comes from. Okay, so you see every time when we want to find the expectation of x, right? So, or the mean of x, what we are trying to do is we use the number of success, the probability of success, which is our p, then you will times how many sample size that you have, or like how many trials that you have. So in this case it's like 60, so you use 1/6 times 60. So this is basically NP. So you use number of trials, which is your n, to time your probability of success, so NP. Okay, so how do you find the variance? So you see, you use 10 to times 5/6. So the 10 is basically your number of success, right? Which is your mu here, meaning your mean here. Then after that, your 5/6. Why? Because out of the 10 times, you might have the chance of 5/6 to get a failure. So that's why you times the probability of failure. So since mean is basically n times p, so we also say that the variance is basically n times p times q lah. Okay, standard deviation easy, meaning you square root your variance. Okay, so in your exam, I try to put everything together. So because that's the end for the part for binomial distribution. So you have a formula for your probability and you have a formula how to find your mean. So you need to know that this symbol actually means mean. Okay, so it's the same thing if they use EX lah, expectation is the same thing. Okay, so this is your second formula and your last one is your variance. So they didn't use NPQ like what I say, they try to use the term of P only. So that's why Q is equals to 1 minus P. So it's basically the same thing if you use NPQ or you use NP then bracket 1 minus P. But this is going to be longer lah, then easier for you to remember than just remember NPQ. Okay, so that's a part for introduction. So now let's go into our example. So we only have like 1, 2, 3, 4, 5 example today. And number 1 to 4 is basically about the new concept. Then the last one, maybe I try to do a long question so you guys can understand better for the binomial distribution. Okay, alright, number 1. So it's very easy. Okay, so for a binomial distribution that have an n, okay, so try to write down everything that given by the question. So the binomial distribution have a number of trial of 80. Okay, so n is 80. So what is 0.4 mean? If you still remember, is your probability of success. Okay, so find the mean and the standard deviation for x. So very easy, just follow your formula. Okay, so for mean, okay, for mean, it will be n times p. Okay, so basically 80 times 0.4. And this is how you get 32. Okay, alright, so let's move on for the next one. So how to find your standard deviation. So you can find variance first. Okay, so for the variance is going to be NPQ, or if you want to follow or get yourself familiar with this formula, then of course you can do this also. It's going to be the same thing lah. Okay, so number, probability for P, and then 1 minus probability of P. Okay, so when you times them together, then you will be getting 19.2. Then how to find your standard deviation? It's basically using the answer just now and you try to do square root. Okay, equals to your variance in square root. So you'll be getting an answer 4.38. Alright, okay, number 2. 20% of the electric components produced by a factory are defective if a sample of 40 electric components is taken, find the number of the components expected to be defective and the variance and the standard deviation. Okay, so this question is basically asking the exactly same thing like number 1. It's just that in a real life application. So that's why you need to understand what is that given. Okay, so you see a sample of 40 electric components. So I think this is pretty easy, which tell you that the number of trial that you have is 40. Okay, then after that you need to see the thing that you want to find, is it the same with the probability that given. So 20% of the electric components produced are defective. So it's good that you try to denote first like what is your random variable here. So for here meaning that my x is I want to find out how many number of defective component. So since x is the number of defective component, it also means that my probability of success is going to be the probability for the component to be defective. So that's why P will be equals to 20%, which is 0.2. Okay, so since then you have your Q is 0.8 lah. Then now you have everything already, then you can start. So the number of components expected to be defective is basically asking you about your expectation. So meaning out of the 40, you are having 20% you expect to be defective. Okay, so easier mean will be basically, or in this case they use expected, right? Then you can just use expectation lah. Okay, so will be equals to NP. So it will be equals to 0.2 times 40, which gives you 8. Okay, so just like that. Then now the variance. Okay, so the variance will be equals to NPQ. Okay, so use your N, 40 times 0.2 and then times 0.8, which will give you 6.4. Okay, so the last one, standard deviation, then you just square root for your answer for your variance, then you get 2.53. Okay, alright, number 3, the random variable binomial distribution have an number of trial n, then probability of success p, given the mean is 12 and the variance is 7.5. Find out the value of n and p. So this is about how to solve equation. So you can see basically you have two unknown here. So now what you need to do is you need to create your simultaneous equation. So now let's try to do that. Okay, so this is for your A. So expectation for x is 12. So if you want to try to put it in your formula, then it will be n times p equals to 12. Okay, then after that your variance is 7.5. So what is the formula for your variance? Then NP. So okay, in this case, right, you have two choices here. So you see you can use NPQ and you can use NP1 minus P. So why is NP1 minus P is more helpful here? Because if you try to use NPQ, right, then what happens is you realize you have 3 variables. Then it becomes very hard for you to solve a simultaneous equation. So that's why use NP1 minus P. So it will be equals to 7.5. But of course you can use NPQ, then you find your Q first, since that you have NP, right? Then you find your Q, then you have your P, then after that you substitute. It's totally fine also to do that. Okay, so since you have NP here, this is our first equation, then this is our second equation. So you do not need to like really shift it over, because what you can realize is basically NP and NP. So you just substitute the whole thing here, then you find your P first. Okay, so from the first equation, then I put in the second one. So meaning I have 12 and then 1 minus P will be equals to 7.5. Okay, so I have 12 minus 12P equals to 7.5. 12P will be equals to 12 minus 7.5 give me 4.5, and then when I divide I will get an answer for 0.375. Okay, so that is my P. So after that, what do I do? Then I continue by using my first equation here, NP equals to 12. So N is the variable that I want to find. Then I substitute the P that I already have. Then I will get my N as 32. Okay, so you can find out your N and P already, so settle. Okay, so now go to B. Want to find out the probability. So this is what we learned in the previous lesson. So probability for x equals to 11. So P x equals to 11 will be equals to, so what is your total number of sample space or total number of trial here is 32. So 32 C 11, then what is your P? 0.375. Then yeah, how many success that you want, which is 11. Then you use total number to minus 11. So 0. Get your Q first. 1 minus 375, you get 625. And then power 21. Okay, so you use your calculator to solve it, then you'll be able to get 0138. Okay, alright, so let's move on for the last two questions. Okay, so in a group of students, the expected number for a student to own a car is 8 and the variance is 1.6, and you want to find out what is the probability for a student chosen is owning a car and the total number of the students in a group. Okay, so this is the same thing like question 3. So, but in an idea that this is an application that you actually need to find out yourself, like what is the information given in the question. Okay, so in a group of students, the expected number, so meaning you have EX equals to 8. Okay, then after that you have your variance is 1.6. Okay, so meaning the same thing, and P equals to 8. And then your, what is that called? Your variance is NP. 1 minus P is 1.6. Okay, you need to know how to find and how to identify the information given by the question. That's the most important thing. Because like statistics, you will have all the long questions, so it's very important for you to know that what is the mathematical symbol or the representation you can use to represent the information that given in your question. Okay, so find the probability for the students chosen own a car. So basically they are asking you to find the P, the total number of the students in the group. They're asking you to find the N. So if you understand the whole thing, then you can solve it like very easily. Okay, so this is my first equation, then this is my second equation, then now I'm going to do the same thing. Okay, so I have 8, 1 minus P equals to 1.6, so 1 minus P is basically equals to 0.2. Okay, so P will be equals to 0.8. Alright, okay, then after that I go to my 1, which is NP equals to 8, and then N will be equals to, 0.8, 8, and then N will be equals to 10. Okay, so it will be better if you can try to answer it in a way that the question can be understanding. So try to write it down, because the question didn't give you anything in like variable and so on. So if you want, you can try to write down the whole thing lah. So like the probability of the student chosen to own a car is like 0.8. Then the total number of students in the group is basically a 10. Okay, alright. So number 5, it is estimated that 1.3% of the matches produced at the factory are damaged in some way. A household box contains 462 matches, and you want to find out what is the... Okay, calculate the expected number of damaged matches in a household box. So meaning you can write down first what is given in your question. Okay, so now let's see. They are giving that 1.3% of the matches produced at the factory are damaged. So meaning that you are looking at it in a way that your success is basically the damaged matches. Your success is basically if the matches is damaged. So that's why you can try to assign first what is your random variable. Okay, so this is to answer your A part. So meaning X, you are trying to make it in a way that the number of matches is damage. Okay, or like, yeah, I should write number of damage matches. It's totally fine lah, yeah, English. Alright, so then you have 1.3, so meaning that the probability for you to get the case that the matches are damaged is basically equals to 0.013. Okay, so the household box contain 462, that's mean your N is 462. Okay, so you want to find out the expected number of the damaged matches, then how do you do that? So EX will be equals to N times P. So your N 462 and then times with your 0.013. Okay, so when you times them together, then you'll be getting 6.006. Okay, alright. Okay, so let's move on. B, find the variance of the number of damaged matches and the variance of number of undamaged matches. Okay, so you might find it like very confused now. So what does that mean by the number of damaged matches? Then what does that mean by undamaged matches? Okay, it's totally fine. Now we try to say this. Okay, so you see, when you find the variance of x, right, they only tell you that x is like referred to the x that you actually assign here. So it's very easy for us to find the number of damaged matches. So how about the undamaged one? So basically you can remember for binomial distribution, right, you have only two outcomes. Then what you can realize here is like the whole thing is okay. I try to do it first, then after that you'll see it. Okay, so the variance of x will be equals to np and then 1 minus p, which in this case then it will be 462 times your p is 0.013 and 1 minus p you will be getting 0.987. Okay, so when you times them together, right, what is the number that you have? So you will get an answer 5.93. Okay, so this is the variance for the damaged matches. Okay, of course, because our x is number of matches, right? Okay, now my question is how do we find the variance of the number of undamaged one? Okay, so basically the answer is the same. Why is that so? Okay, so you see, if now I try to change everything here, so like for binomial distribution, right, if not outcome A happen, then it will be outcome B happen. So meaning if the matches is not damaged, then it's undamaged lah basically. So meaning that what you can see is now when I try to repeat the experiment again, do I have the same N? Yes, I still have the same number of trials, right? No matter I want to find the damaged or the undamaged one. Then after that, what will happen? My P now will be changed to my Q because I want to find the number of undamaged. So you can imagine if this X I try to change to undamaged, then what happened here is your Q will become your P will become your Q. So imagine these two are going to change their place. Then what's the answer you get finally? It's going to be the same because A times B and B times A is getting you the same thing because the number of trials is the same also. So that's why both of these answers have the same answer. Okay, so you can write down. So this is like for variance for, yeah, or you can answer it in a whole fully way because the question give you two things, right? Or you can use the other way is you just try to assign another one. Okay, so okay, we just answer it like follow to the question. So the variance for the number of damage okay is basically 5.93 lah. So if you want to show it, you do not want to straight away write your answer, then you just change it in your question. So variance for number of undamaged okay is basically equals to the same thing. Then now you switch your 1 minus P and P because you want to find the undamaged, so it's basically the same thing. Alright, okay, so move on to C. I'm sorry, I mean this is of course not a good way to write it because like this is how you get from then I suddenly, yeah, so if you can then try to change it up here. Okay, alright, C. Calculate the percentage of the household boxes which contain exactly 8 damage matches. So this is back to the previous lesson that we have. So you want to find out probability for number of matches is exactly 8. Okay, you want to find out the percentage. So you remember, after you find out the probability, you need to find the percentage. So you have a total of 462. C8 is going to be damage. So the probability of damage, then power 8, probability of undamaged is going to be 462 minus 8, which gives you 54454. Okay, so you use your calculator and you'll be getting 0.1039, which if you change it, then it will give you 10.39%. Alright, okay, so that's settled for D. For C. Okay, for D, yeah, I think this is something special about this question, so I take it in so I can like explain like more example or more special question to you. Okay, calculate the percentage that at least one from the sample of 2 household boxes contains exactly 8 damage matches. Okay, so now you'll find it like, what is this question asking? Okay, so now instead of like finding like the number of matches, whether it's damaged or not damaged, right? They are talking about whether a household boxes have 8 damaged matches or not damaged matches. So meaning that in this case, your binomial situation, right, will actually change to not your x now is actually not the number of matches that is damaged already. Your new variable now is basically whether the box contains 8 damaged matches or not, because you only can have 2 outcomes. So meaning that yes, you have 8 damaged matches. The second one is no, I don't have 8 damaged matches. So what I will try to do is I'll try to assign a new random variable. So I'll try to write y. Okay, so basically what is my y? My y is the box, the household boxes. So you can try to see what is the difference between the y and the x here. So the x here is basically telling me the number of matches, but y, I'm looking at the number of the household box now. Okay, so the number of household box, or yeah, it's okay. The household box which have exactly 8 damage matches. So this is my new y now. Okay, so now what I want to find the probability for at least one of the sample of the 2 household boxes contain exactly 8 damage. So meaning my n here, my number of sample space now become 2, because I have a sample of 2. So what is my probability to get a household box that is having an exactly 8 damage matches? That is what my answer is for the part C. The probability for me to get a household box which have exactly 8 damage matches is basically 0.1039. The probability for failure to do this will be equals to 8961. Okay, I hope that you can understand. Okay, so for D, right, you have plenty of ways that you can do that. So now if I'm writing in this way, meaning that you can see I'm trying to do binomial. So meaning I will try to solve, I'll write here because I scared I don't have enough space to write everything. So I'll write probability for my number of household boxes which have exactly 8 damage matches, at least 1. So meaning more than or equals to 1. Okay, then what you can try to do, you can do in several ways. So meaning I can either do like 1 minus p y equals to 0. Okay, or in another way, I can, since my sample space is only 2, then the thing that you need to do is only 1 or 2 lah. So if you don't want to use minus, you use plus also can. So meaning I can use probability of y equals to 1 plus probability y equals to 2. Meaning like one of the 2 having exactly 8 damage, or like 2 of them all having exactly 8 damage matches. Okay, then how do you continue? This is all, sorry. Okay, so how do you continue? You just continue with 1 minus, so n c r. Okay, so since this is 0, so meaning 0.1039 power 0, 0.8961 power 2. Okay, or if use this, then meaning that you will get a 2c1 times this, and then I have the other one plus 2c2 . I'm not sure whether you realize it or not, but I hope that you realize it. Like every time when you want to do like C0 or C for the full number, actually the first one you left with Q, then the last one you left with P. Meaning like normally you already know that for the starting here will be like basically equals to 1. Then this one, the whole thing at the back here and the front will actually become 1. Then you just, what does that mean by you only left with the Pn and the Qn lah? Yeah. Okay, so this is the first way that you try to do. So no matter which one you use, you will be getting the answer for 0.197. Okay, now if I don't want to use binomial, can I use the other way? Yes, you can do that. So how can you do that? Tree diagram. So at least one, right? Meaning that the other way that you can try to do is you don't need to use binomial because you only have 2. So it's totally fine if you want to draw a tree diagram. So what you can do is at least one. So meaning that I will use the probability for me to get one okay, both contain exactly 8 damage matches plus y dash, meaning not y. First one is exactly 8 damage, the other one is not. Then I'll plus another one, which is the first one is not, the second one yes. I can do this also, then I get the same answer. So meaning like what happened here is 0.1039 times 0.1039, then the other one is 0.1039 times this one, then the other one is this one times this one. Or I can also use 1 minus probability for it doesn't happen at all. So meaning 1 minus this one square, I also get the same answer. Okay, so it depends on which approach you want to take. So I'm not sure like from the Monday explanation you get the idea of not that actually binomial distribution, right, is something to do with your tree diagram and so on. It's just basically about the probability that you have learned before, but it's just that with a bigger sample size, it's very hard for us to like continue like for such a long process. So that's why we come up with the distribution thing. Okay, so it's the same thing like for the small sample size, whether you want to draw it out with the tree diagram method or you want to do the binomial, it's totally fine. It depends on you. So just make sure that you try to understand that everything in your statistic, right, actually they are going to like interrelated to each other. So you can realize that for the previous lesson you also have question like the coding inside. So that's why you must need to understand everything and you know how to like relate them together and make it as a whole. So do not try to like memorize like this is binomial and this is normal and this is like what something like that. So you just understand everything so you are able to like go through like understand what the question want and what's the approach that you can take. And it's definitely not just one approach. You can use several things to like all the different kind of method to help to get you the answer. Okay, so I hope that you can understand everything. So it will be like much more question for today, so use your time to do your exercise. All right, thank you.